Hey guys, Mr. Backwork here. In this video, we're going to look at annuities.
So an annuity is a sequence of equal periodic payments that you're putting into an account as opposed to just putting in one lump sum. And we say an annuity is ordinary if the deposits are made at the end of each period at the same time that the interest is posted in the account. Now for the examples that we do, we're only going to use ordinary annuities. So we're going to look at an example where we're starting a retirement account. And what we're going to do is we're going to put $500 in our account at the end of each quarter. And we find an account that's going to pay us 8% interest, and it gets compounded quarterly. So we're going to look at our account at the end of each quarter throughout the year. So we're going to look at the end of the first quarter, the end of the second quarter, the end of the third quarter, and then at the end of the year. So at the end of the first quarter, we're going to make our first $500 payment into this account. Now we're not going to gain any interest on that because we literally just put the money in there. It hasn't had time to accumulate any interest. But then, as we move to the end of the second quarter, we're going to add on another $500. Now what's going to happen in here is that original $500 that we had put into our account is going to gain some interest. So I want to think about using our compound interest formula to help me try to figure out how much interest I'm actually getting. So if you think about your compound interest formula, that's A equals P times 1 plus R over K to the power KT, where R is our interest rate, K is the number of compoundings, and T is our time in years. So as we're looking at what's happening in here, we've really got a principal amount of $500 times 1 plus our interest rate is 8%, so that's 0.08. And we're compounding this quarterly, so our K value is 4. Now, with the power, we've got that K value again, so I'm going to plug in the 4 there. But here, we're just looking at 1 quarter, so we're not even looking at a full year. So the T value is just going to be 1/4. Now, what's going to happen in here, if I take 4 times 1/4, then that power just turns into a 1. So I've really got 500 times, now inside of my parentheses, if I take the 0.08 divided by 4, I'm going to get 0.02, and then if I take 1 plus 0.02, I get 1.02. So at the end of each quarter, we're really only getting 2% interest. So at the end of the second quarter, we're going to have that additional $500 that we had in there, but then I need to take this original $500 times 1.02 to figure out what that would be with my interest included. Now, if I go to the end of the third quarter, I need to add on another $500. What I'm going to have to do is take this 1.02, because that's the interest that we're getting for each quarter. I'm going to have to multiply that by this $500 that we put in at the end of the first quarter. But we already multiplied it by a 1.02 once, so really this is going to turn into a 1.02 squared. But then I also have to take this $500 from the second quarter and multiply that by the 1.02 because that's gained some interest on it now too. Now as we get to the end of the year, we're going to add on another $500 payment. And then I'm going to have to go back through and multiply each one of these $500 payments that we already had in our account by that 1.02 again. So this first one, instead of being 500 times 1.02 squared, if I multiply by 1.02 again, then that power is going to turn into a cubed power. The second one, if I multiply by another 1.02, then that's going to turn into a squared. And then this third one, this will be the first time that this one has gained any interest on it, so I'm going to have to multiply that by 1.02. Now, if I were to take all of this and type this into my calculator, it should tell me that in our account, we've got $2,060.80. But instead of just calculating the individual interest payments, we've got a formula that'll help us figure out the future value of an annuity. So to find the future value of our annuity, our formula is going to look like R times 1 plus I being raised to the power of n minus 1 over I. Now in this formula, R is the amount of money that we're constantly paying in. I stands for the interest per compounding, And we can find that by taking our interest rate divided by the number of compoundings per year. And then that N value is the total payments that we're making over the life of this annuity. And we can find that by taking the number of compoundings times the number of years. So let's revisit that example where we were looking at putting away $500 per quarter. We get 8% interest and we're compounding this quarterly. Now we just looked at what would happen at the end of 1 year. But let's say we continued this for 20 years. Then let's figure out how much money we're going to have in our account at the end of the 20 years. So I'm going to use that formula. So in our formula, the R value is the money that we're paying in at the end of each period. So that's our $500. We said in order to calculate the I value, we would have to take our interest rate divided by the number of compoundings per year. So my interest rate is 0.08, and since we're compounding this quarterly, there's 4 compounding periods per year. So my I value is going to end up being 0.02. So I've got 1 plus that 0.02. Now I have to raise that to the power of n, and n is the total number of compoundings. So if we're compounding this quarterly, that means 4 times per year, and we're letting this go for 20 years. So if I take 4 times 20, then that n value should end up being 80. But then I'm supposed to subtract 1, and then I have to divide this by that I value. And earlier on we said the I value was 0.02. So I've got all of that information plugged into my formula. Now I'm probably going to have to use my calculator to help me out here. When I type all of this into my calculator, I should get 96,885.98 cents. So if we continue making $500 payments at the end of each quarter, then over a span of 20 years, we'll end up with almost $100,000 in our account. That's going to be it for this video. Thanks for watching.